everyone. Thank you for coming. Thank you for the introduction as well. My name is Maria. I'm a software developer working for Sky in London. More specifically, I work in the content discovery department, where we build the recommendation API that millions of users use every day. If you're interested in that, grab me afterwards, because that's not what I want to talk about today. What I want to talk about today is running AWS dependencies locally and how we can make that easier. To describe the problem, I'm going to start with a story, so get cozy. I'm going to leave it up to you to decide whether the story is real or not. So, once upon a time, there was this developer called Oscar. This is our developer. He's a Scala developer. And one day, Oscar found this very annoying bug in production, and he didn't know how to solve the problem. So he thought, what about I try to run my project locally, and just maybe that will make it a bit easier for me to debug what's going on. So Oscar has to run application A. A is a Scala application. But then he notices that A has a dependency on the DynamoDB from AWS. And then it also has dependency on S3. And then, upon further investigation, he realizes A depends on another application, B, let's call it, that depends on DynamoDB, and then this depends on Kinesis as well, and then B depends on another application, you get where I'm going with this, and then C depends on S3 service, and then to make it even more complicated, these live in different AWS accounts. And by this point, Oscar's like, what is going on? So what are the steps that Oscar would have to take? So it would be something like this. He'll need credentials for both accounts. He would need to create some testing resources. In his case, it's loads of them. And that's given that he's not allowed to use some testing resources that are already there. He'll have to add some testing data, and then given that all the ports align and all the planets align, he can just start the applications, and this will just work. But I want to see how we can make this better. So what I'm proposing is we use something called LocalStack. So LocalStack is a testing framework that simulates cloud environments, more specifically AWS in our case. So what LocalStack provides is an image we can then use with Docker, and that would emulate the AWS environment, and then we can change our application to talk to this local AWS instead of talking to the real cloud. So what would we have to do? Well, obviously first we need to install Docker, and I suggested Docker Compose as well. And using Docker Compose, we can define something like this. So we're going to say Docker, okay, I want a container that uses the local stack image. And in our case, let's say we only need the DynamoDB and the S3 services. So I'm going to say just spin those up on these ports. That's pretty straightforward. And then you could use, I said it's a Scala application, so we could use the SBT Docker Compose plugin. And all you have to do is enable this plugin, and then from within SBT, you could spin up this container running the local stack image. If you don't want to add a new dependency on your project, you could simply use your terminal and just run Docker Compose up, and it will do the same thing. Cool. But now what we have is a container that has some sort of local cloud, but doesn't have any resources whatsoever. And what I usually like to do in this situation, I want to look at the CloudFormation of the project. You may be familiar with CloudFormation if you've used AWS before. CloudFormation is it's an AWS-specific template where you can define your infrastructure. You may be familiar with Terraform instead. Terraform is another infrastructure as code tool. So that's a nice place where you can look and just see a very clear list of all the resources you need. I have a very simple example here. This is just creating an S3 bucket, and it provides the name. That's all it does. So by looking at the CloudFormation, and by installing the AWS CLI, I will be able to create a bucket on my local AWS. And the way to do that, the only thing that's different from talking to real AWS is providing that endpoint URL parameter that tells it to talk to your local one on the given port. Cool, so now we have some resources. But how can we make our application talk to this local AWS? Well, the only thing you really have to change is your client. So by default, the client will try to communicate to the real AWS. But what you can do, you can provide this endpoint override and do the same like we did in the CLI, just point it to the local host one. And everything else is the same. So in this example, I'm just writing something to an S3 bucket. Nothing else changed apart from the client. So in the real world, you want some sort of config that decides which client to use. This is just talking to the local one. And after you have all of this, so you have your container, you have all your services created, you've pointed your application to talk to your local AWS, then you can just start the application. But at this point, Oscar is pretty bored. There's still loads of steps. So I started wondering, can we do a bit better? Is there anything we can do to speed up this process? And I decided to write an SVP plugin to do these steps for me instead. Because there's a lot of manual work I had to do to set that up. So here on one side, you have the steps we talked about. And the new world is like my ideal steps that the plugin would follow. So let's see what changed. I took these 3 steps, and I just combined them into one. So spinning up the container, running the services you need, and creating the resources, everything will be done automatically for you. And then, if you take out the steps that don't necessarily need to happen every time, like installing Docker, because ideally you'll be running from the same machine, and you take out the update to the client, because that's just a code change you can do once, we basically managed to reduce the number of steps by 2. So let's go through what the plugin does. So the plugin will spin up a Docker container, and you will have 2 SBT settings you could set at the moment. It has the location of the cloud formation that needs to be using, and it also has a list of services that you will need for your application to run. And this plugin will only start up the requested services. It will create all these resources from the available CloudFormation. And for those of you who are familiar with CloudFormation, it will do all the substitutions needed. What I mean by that is it will look at the parameters and just replace them where necessary. And it also provides some commands for starting this container, stopping it, and just printing out the CLI commands if that's all you're interested in. What it doesn't do at the moment, it's really early stages. It only works with DynamoDB resources at the moment, and it only supports YAML CloudFormation. With that, I want to show you how this works. So I have set up a project. So this is actually the repo where the plugin lives. And this repo has 2 example projects I've created. The one that doesn't use the plugin follows exactly the same steps I've talked about at the beginning. And if you look at the README, I wrote all the steps, so if you want to try that out, you can just follow these steps. In terms of resources, I've added steps for creating an S3 bucket and a DynamoDB table, and you can see how it can get very complicated really fast if you want a very complicated table. But I'm going to leave that for now. I want to show you how the example with the plugin works. And I have a README as well. So this looks much nicer, right? You just have to have Docker and the CLI installed. Unfortunately, I wasn't able to get rid of this step that kind of needs some dummy credentials, but that's fine. It's really easy to set. You just have to run AWS configure and just give it some random values. It doesn't have to be anything real. And then you can use this command, I called it local AWS start, to spin up the container with all the services, and then you can just run your application. Now, if we look into the build.svp for this project, the only settings we had to add is this CloudFormation location that just pointed to where my CloudFormation lives, and the list I mentioned with what services I'm interested in. As I said before, at the moment it only works with DynamoDB, so I can't even add something else here. And if we look at the project, in the resources folder, I have my CloudFormation. It looks something like this. So it has a list of parameters. And I have two resources in my case. I have a DynamoDB one, and I have an S3 bucket that will be ignored when I run it. Cool. And the project itself, it just writes something to the table and then reads it back. It's not very complicated. So let's actually run it, because that's more exciting. So I'm going to enter SBT for this project. And in the meantime, I just want to prove that I don't have any Docker containers whatsoever running. OK, let's go to the project. The plugin. Cool. Let's make this a bit bigger. Can everyone see? Yeah? Cool. So as I said, the command you have to run is local AWS start. And this will create the container. It will tell me that the services that it will be running, it will start up are the, are the DynamoDB tables. And this is the CLI command that was generated automatically from the CloudFormation. And it is a quite complicated one. It's not just giving the name of the table and some simple attribute definitions. If you read it closely, it has some global secondary indexes as well. So if you were to type this by hand, it would be quite tedious. And the JSON you see here, this is the reply. And everything was fine, so it created this table for me. So let's just make sure that actually happens. So if I go over here, make this a bit bigger. So if I do Docker PS again, I now have my local stack container running. And I can prove it has a table by running this command that says, points to this local DynamoDB and list all the tables. If I run this, it created a table. And now, if I go back to my application and actually run the application, this will talk to this local Dynamo. And you can see here, it wrote something to the table, and then it took it back. So it's pretty straightforward. Now, another command you could be running is you can kill the container. Stop. Sorry. So this will just remove the, if I run it, give it a second. OK, so now it's gone. And if you're just interested in seeing how the AWS CLI commands would look like, you can run local AWS CLI commands, and it will just print those out. When you run this, it doesn't look, at the moment at least, it doesn't look at the build.sbt to see what services you're interested in. So as you can see, the last line, it says that the S3 service has not been implemented yet. Cool, so that's pretty straightforward. And I didn't have to read any CloudFormation. I didn't have to write any of this manually. The plugin just did everything for me. Oh, sorry. Back to my presentation. So I created a GitHub repo with all of this work, so you can go and check it out. You can play the plugin if you're interested or if you find it useful in any way. I've also linked to the local stack GitHub because I have a very long list of S3 service, AWS services that are available. And I'm going to post these slides on Twitter if you're interested. But before I end, I wanted to add something else. This is something I started thinking about months ago, and this came from a real problem I had. It took ages to run some projects with lots of AWS dependencies locally, and I started thinking there was something I could do to improve it. And it was really fun doing so, because I've never written an SBT plugin before. I didn't know how to test it properly, and I now know these things. I've learned how to publish it and how to integrate it with CircleCI and all sorts of things. So it is a very educational exercise for me. So what I want to inspire you to do is to think about all the things that you do every day and they take a long time. I want you to think about, is there anything I can do to improve the life of my team and just improve my life. Because I'm sure everyone has something that takes, I don't know, 30 minutes every day or so. So if there's only one thing you take away from this talk today, is just this idea of, can I make it better? Thank you.
Thank you very much for sharing your knowledge with us. We have 2 questions for you.
Oh, let me just...
I think, yeah. So the first one is, do you think about integrating it with Docker IT Scala, I think?
No, I didn't, but that's a good suggestion. I can look into it. Whoever wrote this, thank you.
Okay, and the next one is, can you use Scepter for deploying the CloudFormation?
I'm not familiar with Scepter, so I'll have a look. Sorry about that.
Okay,